Every time hurricane season rolls around, you see the headlines, right? Some are screaming that storms are getting stronger and more frequent, while others say it's all just media hype. So what's really going on? Let's dig in and separate the facts from the fiction.
It is so easy to get totally lost in all the noise. One report says one thing, and the next day you see something completely different. To get to the truth, we're going to skip the headlines and go straight to the source, the data, from places like NOAA and the IPCC. We're going to look at what the science actually says about how often storms are happening, how strong they're getting, and what that really means for all of us.
You know this quote from the American Meteorological Society journals? It pretty much nails it. This isn't a simple yes or no question. The real story isn't that we're getting more storms. It's that the storms we do get are, well, they're built different. Let's break down what that means. All right, first up, let's just tackle the biggest myth right out of the gate. This idea that we're just getting way more hurricanes than we used to. This is the one you hear all the time. But what do the actual global numbers show?
So just take a look at this. This chart shows the total number of tropical cyclones around the world, going all the way back to 1970. And that's a key date because that's when we started having good satellite coverage. And you can see, yeah, the numbers jump around year to year, but that trend line, it's basically flat. There's no clear sustained increase in the total number of storms hitting the planet.
And look, this isn't just us cherry-picking one chart. All the major scientific groups are on the same page here. The IPCC, that's the UN's climate science body, they see no clear increase. NOAA says the same thing. And it's really important we focus on that post-1970 satellite era, because before that, we honestly just missed a bunch of storms that spun out in the middle of the ocean and never made landfall.
So here's the bottom line on this myth. The idea of way more hurricanes just doesn't line up with the global data. The reality is a whole lot more subtle. The total count is holding steady. But the character, like the personality, of the storms we do get, that's what's really changing.
Okay, so if the sheer number of storms isn't the big story, then what is? Well, this is where things get really interesting. The data is pointing to storms that are, on average, just plain more dangerous. They're packing a much bigger punch in a few different ways.
So here are the 4 big ways storms are changing. First, a bigger chunk of them are becoming major hurricanes. You know, the really scary ones. They're also powering up way faster, giving people less time to get ready. They're dropping incredible amounts of rain, and they're riding on top of higher oceans, which makes that storm surge flooding so much worse. Let's break each of these down.
So let's start with intensity. Even though the total number of storms is flat, the proportion of those storms that blow up into a Category 3, 4, or 5 monster, that seems to be going up. And we can see this signal pretty clearly in the North Atlantic basin. So maybe not more storms overall, but a higher chance that the ones that do form become truly dangerous.
Now this next idea, this is one of the scariest things we're seeing. It's called rapid intensification. This is when a storm goes from, something to watch to an absolute monster in like 24 hours. Think about storms like Harvey or Ida or Ian. They just exploded. And the research shows it's happening more and more. NOAA even called this trend in the Atlantic highly unusual. It's a huge problem because it just guts our warning time.
Okay, now let's talk about the wetter part of the story. It's pretty simple physics, actually. A warmer atmosphere can hold more water vapor, about 7% more for every degree Celsius warmer it gets. And this isn't just some textbook theory. We see it in the real world. Like one study of the 2020 Atlantic season found that extreme rainfall was up to 11% higher than it would have been without that extra warmth. And all that extra water is what causes that devastating inland flooding way far from the coast.
And finally, there's the storm surge. Now here's the thing. The hurricane itself doesn't even have to be any stronger to cause worse flooding on the coast. Why? Because the ocean itself is giving it a head start. Global sea level has already come up by about 9 inches since 1880. That means every single storm, big or small, gets to launch its attack from a higher platform, pushing that wall of water much further inland.
So all this leads to a pretty logical question, right? If the total number of storms isn't really going up, why does it feel like we're constantly hearing about record-breaking damage and billion-dollar disasters? Well, the answer isn't just about the storm itself.
It's really a two-part problem. Think of it like a collision. On one hand, you have exposure. We have been building like crazy on the coasts for decades. We've just put way more people and way more expensive stuff directly in the bullseye. Then, on the other hand, you have the changing hazard. The storms themselves, as we just saw, are bringing more rain and higher surge. So you've got more stuff in the way of a more dangerous threat.
And this is where things get a little complex. Scientists are still debating exactly how much of the rising cost comes from which factor. Some studies try to normalize the damage. Basically, they adjust for inflation and how much we've built on the coast. And some of those studies say, hey, once you account for that, there's no real trend. They blame it mostly on us building in risky places. But other, newer studies are finding an upward trend even after they adjust, suggesting that the beefed-up storms are already making a real, measurable difference in the damage bill.
And just to add one more layer of complexity, the Atlantic Ocean has its own natural rhythm. It has these long, multi-decade cycles where it's more active and then it's quieter. We were in a quiet spell back in the 70s and 80s, and we've been in a very active period since the mid-90s. This natural up and down makes it really tough to perfectly tease out the long-term climate signal from all that background noise.
Okay, so the picture is definitely complicated, but it is not hopeless. Not at all. In fact, really understanding what's changing is what gives us the power to respond in a smarter way. We actually have way more control over how bad a storm's impact is than you might think.
And this right here is the key to everything. Just think about risk like a simple formula. Risk equals hazard times exposure times vulnerability. The hazard, that's the storm itself. The exposure is all the people and property in its path. And the vulnerability is how well we're prepared for it. Now, changing the hazard is a long-term project, right? But we have direct, immediate control over the other two parts of that equation.
So what does that look like in the real world? It's not some abstract idea, it's a very practical playbook. We can invest in even better forecasts and warning systems. We can demand stronger building codes that actually get enforced. We can be much smarter about where we allow new development. We can protect and restore our natural defenses like wetlands and dunes. And we can make sure insurance actually rewards people for being safer. All of these things cut down on damage, no matter what the storms of the future look like.
All right, let's wrap this all up. Are hurricanes getting worse? Yes, but probably not in the way you hear about in most headlines. The data doesn't really show more storms. What it shows is that the storms we do get are coming supercharged. They're stronger, they're wetter, they're intensifying faster, and they're all happening on top of a higher ocean. They are essentially loaded for more impact.
And that leaves us with a final, really important question. We know that risk is this triangle of hazard, exposure, and vulnerability. We know the hazard is changing, but we also know we have direct control over our exposure and our vulnerability. So, which side of that triangle can we change the fastest to build safer communities starting today?